Hello and welcome back to this video on infrastructure as code in DevOps. Now in this course, we're talking a lot about infrastructure as code. So it is important to understand the value of infrastructure as code in DevOps. But in order to do that, let's look at how infrastructure fits in the traditional software development project timeline. Now this that you have on your screen, a timeline, is common to a lot of organizations where once a funding's been signed off on a project, a team kind of gets formed, they flesh out the requirements with the customer, help prioritize it, and hopefully at that point start coding up. It's at that point that some project manager in the organization is going to raise a request for an environments team or a procurement team to provision, dev, and test infrastructure. Also, that team will have to request for infrastructure for production as well. Now, that process in an organization can take anywhere from days to weeks, sometimes even months. And it's at that point that project ends up burning a lot of money and resource waiting for infrastructure to arrive. Now, because the infrastructure arrives very late in the process, you're still unable to test the software that you're creating. You're still unable to show it to the customers and gather their feedback. So if you haven't noticed, this part is where the real problem lies. Now, it causes a lot more issues, and let's look at what these issues are. The old-style ID server management introduces two key issues. The first one is environment provisioning becomes a tedious task. It's simply because there are so few environments that are available, and because the environments are so few, there's little value in automating the deployment process or the provisioning process. Or because you don't have control over the infrastructure, you have no way of automating the provisioning as well. So that leaves only a couple of people in the organization who understand how to set up that server from scratch. Now, you would hate to be that person on call supporting that application to get a call at 2 a.m. saying the server's decided to go down and it's not coming back up. And you have to recreate that server from scratch. Dreadful, right? And that's common. It happens in organizations where server provisioning is a black art. It's something that not many people are aware of. And it causes a lot more bad issues. But one interesting thing that it gives birth to is we start treating infrastructure as pets. You know, these unique servers have their own names, so it's called application test 0105 because, hey, we only have 3 servers, and these are the 3 servers that are available for testing. What it also causes is a configuration drift. Now, because infrastructure for production and infrastructure for test is separate and different, usually what ends up happening is that the test infrastructure gets less love. For example, if you were going to set up a SQL server instance, you will set up the SQL and the web server both on the same node. The SQL SKU will be a developer SKU, whereas in production, you're going to have a multi-server environment with a load balancer with some kind of mirroring as well. And what this causes is the developers are never able to test their application with production-like infrastructure until they get to production. So when they deploy into productions, failures happen, and the blame gets pinned on the operations team. So if you don't have the right infrastructure available all the way through in your pipeline, then you will have these scenarios. The other problem it introduces is configuration drift. Now, because the servers are so different, they need to be treated separately, just like snowflakes. If I'm going to patch the server with my dev environment, it has a different version of Windows, it has a different type or a different SKU of SQL Server, it needs to be patched separately as compared to production. And now you have this configuration drift. The other problem it causes is if I'm creating a certain configuration on the server, like I want to create a folder called log, because that process is done manually across all the servers, you may find that on certain servers that folder is called logs, on certain servers it's called log, and they both may have different capital, lowercase, and inconsistencies. And when the application gets deployed, it doesn't find the right folder because it was provisioned or configured manually incorrectly, and then that also causes issue. So the old style ID server management has its own challenges. Now, what you need to think about is infrastructure for code, or is it worth treating infrastructure as code? So this concept of infrastructure as code, and let's take this, infrastructure as code, is creating programmable infrastructure. So creating scripts to provision your infrastructure rather than setting up the servers or the infrastructure manually. Now, the benefits that it offers is when there are issues, you can obviously run your automation to provision infrastructure again. It offers consistency, whereas the same automation is run across the different environments and the different servers you have. Less involved process, so less dependencies on individuals as well. But a question that I want to bring up is, if you're provisioning your infrastructure programmatically, but the scripts that you're creating or the programmatic scripts that you're putting together assume a start state, then are they really effective? Let me give you an example. So if I have been asked to create a web server, and my script that is provisioning the web server assumes that the underlying operating system is Windows Server 2012, or assumes that there is already .NET Framework 4.5 installed on it, then all the script I'm going to put together will just be from that point onwards, which means if the base state changes, then my scripts are going to fail. Is that really useful then? You might be programming your infrastructure, but your programmed infrastructure still depends on a base state, not as effective. So let me introduce you to a concept called the desired state. And don't panic if you don't really get the gist of desired state, because we have a lot of videos planned further in the course where we will go into great detail on desired state. But what I really just want to get across is the concept of idempotent, which means if you provision your infrastructure and the scripts that you're using to provision your infrastructure are idempotent, then no matter you run them once or you run them several times, the result is always going to be the same. What it also means is you do not rely on the base state of the infrastructure. The base state could be Windows 2016 now. The base state could be that you have ASP.NET 3.5 instead of 4.5. The OS is capable of working out what its current state is and what the desired state is, and bridging that gap by creating the script itself. Now at the bottom there, I've got a pointer which says imperative versus declarative. I want you to take that away and Google it, because in a separate video, we'll cover that in great detail. So what is infrastructure as code? Infrastructure as code really just means treating your infrastructure, which is running the software, as part of the software. What it also means is any dependencies that you have within the application should be treated as the software itself. And so it should go through the same application lifecycle management process that the code goes through. So what are the business benefits of infrastructure as code? There's no point doing infrastructure as code if we don't realize any benefits from it. The benefits, of course, are you're now versioning your scripts that you're using to provision the infrastructure. That means they can go through the same version control, the same code review process, the same CI process, the same unit testing process. How nice would it be to be able to unit test a server provisioning process? How nice would it be to be able to test a firewall change, a network security group change? How nice would it be to be able to just spin up the SQL Server instance by running the script as part of your CI process and validating that it always works, so that when you need it, it doesn't let you down. What it also allows in the grand scheme of things is bringing your application developers and your infrastructure people together. So when infrastructure changes need to be made with software changes, they're done in union and not in separation, which reduces the risk and the surprise later. But really, the two key problems that it solves is it reduces the dependencies on people, it reduces the configuration drift, and now you don't need to treat infrastructure as pets. You can treat them like cattle. Now that we're clear what infrastructure as code is, you would question, what tools do I have available to help me deliver infrastructure as code? As you can see, there's no lack of choice. If you were to Google it, you'd find in excess of 50 tools that are available. Now, these ones that you see on your screen are the ones that have made a great name for themselves, purely because they are very popular in the open source or have product propositions that are used by the unicorns like Facebook, Netflix, and the likes. Puppet, Chef, Salt, Ansible. The ones that I don't have on this slide are Vagrant, and there are several other as well. The Microsoft way of doing it is using PowerShell DSE, which we will be covering as part of the videos in the course later on. Right, so that's infrastructure as code for you.